All right. Hello, everyone. Yes. I'm Dr. Gate Husari. Please feel free to call me Dr. Gate, Dr. Husari. Hello. And I'll be your professor for this course, Data Analytics. One of the main reasons that data analytics is such a fantastic domain, because in modern world, we are drowning in data. Everybody generates data. You talk to any company, Netflix, Amazon, ETSU, even a startup company who's trying to sell ads to other companies. They call that ad analytics or marketing analytics in some contexts. All of these people can give you plenty of data. The big problem is what to do with it. What does it mean and what to do with it? A friend of mine a few years ago got hired by Cisco to do research and development for Cisco. And the first question, not actually a question, the first request from his boss was, here is 16 terabytes of routing data, routers collecting data. Learn something. Tell us anything that we can do to enhance our service. So basically, this field, what makes this field so fantastic is that there are many sensors that collect data. We live in the digital world. There are cameras that take images of us in multiple places. There are microphones, even your Google Chrome or Edge, when you open, especially Google Chrome, absolutely shameless browser. If you open Google Chrome, just set Wireshark to listen. What does your Google Chrome do once you click on it? It generates over 30 messages to different services telling them that you opened your browser. Can you believe it? One of them is YouTube, another is Facebook. So basically, the data is getting generated all over. Your information is being collected, like you open Amazon, you check Google Shopping, you go to YouTube, all of these services talk together. A lot of market in this data. And the big question becomes, what do we do with this massive data? How can we use this data to generate profit or to make the world better? In a nutshell, this is what data analytics is all about. How can we deal with data to generate knowledge, to extract knowledge from this data? The job market for data analytics, absolutely fantastic. Here is a job that was posted. By the way, this is not rehearsed. I just jump on website and I'll find things posted all the time. This was posted 5 days ago. Data analyst jobs are being posted every day. And the main reason for that, because everybody has data and data generates money. Now, if you go to Toyota or any car company and you lease a car, is anybody leasing a car? All right. So 5 years ago, I leased a car, a Toyota. So basically, the deal was, and if you go now to lease a car, they're going to tell you the same thing. They're going to tell you something like, hey, here's the deal. You drive the car, this amount of mileage, you don't exceed it, and in 3 years, you get to give us the car, or you pay this number, and you buy the car. Where does this number come from? How do they know what's going to happen in 3 years? How do they know what's the car value in 3 years? They have data analytics team. There is old school and a new school, but they have a data analytics team. The old school, they work on purely prior experiences, where the new school uses data-driven data analytics to predict the future, not just based on the car that you took and the average that everybody's doing with Toyota. No. Are you a student? What's your credit rating? What's your gender? What's your birthday? What's your job? What's your salary? All of these come together to try to provide prediction for you, as much personalization as possible for you. And then they come up with that number. That's how people make money. The more you can generate data specifically to each person, they call that micro-marketing. And that's the business now. Now, that's why many companies now are coming, many startups, they call themselves ad marketing, ad analytics, micro-personalized marketing. The first big company that followed that approach was Coca-Cola. They changed the way everybody's thinking. Coca-Cola is such a big company, right? They decided they're no longer going to pay very famous people to do their advertising based on their data analytics. They made the huge decision. What they did micro-marketing. Basically, they hired over 100,000 social media influencers. And they asked them to talk about Coca-Cola and advertise it in some way, using videos or TikTok or whatever. They did not pay a big company like YouTube, or they paid people like us, only rich and famous. But anyway, so those people have a lot of followers and they kind of advocated for Coca-Cola. How was that decision made? Using data analytics. Ross, the store, they open places in several areas based on data analytics. They buy data about the needs of that area, and they use that data in order to invest. So they can buy a physical place, hire people, and open a store. That's how this business works. So I absolutely urge you to come here, not necessarily Indeed.com, any website that offers job, and check the market out there. See what's required here, and we want to map to that. For example, this is a remote job. Let's take a look. What do they want? Yes, so now online people, you can see this. This is the job that I opened. This was posted 1 day ago. Let's check another job. Let's check this one. Again, look at this. They want people who can do ETL. Now, there is a fantastic tool called Oracle Developer. It's not here, but as a student, you get the right to download and use that tool. Oracle Developer, you will find a YouTube video. It will show you how to parse the data, take it as input from XML or CSV or SQL or JSON, and generate any of these inputs. So basically, it's a magic tool that takes in one format and spits out any format you want. So if somebody says, hey, I have an XML file, we shouldn't freak out. It's fine. Yes, your data is in XML format. We just take it and generate a CSV file. In this course, we'll be working with a CSV file, the most famous file format around the world. But if it's JSON or CSV, or XML, it's all fine. Okay, those particular people, they want SQL, they want Python. Python is one of the tools we're going to be using in this class. This class, we offer two paths. You can do the R path or the Python path. Either way is fine. So those people, they want Python. And they want, look at this, they want Panda. In today's lab, we're going to use Panda for the first time, if you haven't used it before. But basically, the main idea that I'm trying to communicate, I spend heaps of time to map this course to market needs, and I keep changing based on those needs. So to complete the equation, the success equation, I urge you, check the market, and most of these jobs, they don't want a bachelor's. People are tired waiting for bachelor's, let me tell you. Nobody wants to wait for students to get degrees. And I would also like you to see the job market. Look at this. It's only days. These jobs are being posted like on a daily basis. So this is another job, up to 125,000, totally remote, 2 days ago. Look at this. Bachelor preferred. Can you see the salary? You see that it's preferred. The market is not waiting. We did not do a good job 10 years ago. I did not prepare enough data analysts. Now is the time. Everybody wants data analysts, but there are none. So let's check the job. I'm going to save this because look at this. We need somebody who can do statistical machine learning. Okay, what does that mean? Statistical modeling, such as linear regression. Now let's go to our syllabus. This is where we show you the quality of this course. Let's take a look here. And look at this. In week 5, we're going to be talking about linear regression. Once we learn how to collect data, how to clean it, and provide quality measures, we're going to jump on linear regression. So that's a check. That's their first request, linear regression check. Logistic regression is in the same way. Linear models, data visualization. Data visualization, we will start early. We will be doing data visualization all through the course. How to explain your data through images. Sometimes it's easier. You show an image and it shows you like how something improves or declines. Feature creation, that's going to be in week 9 on October. We're going to be talking about classification, and feature extraction is one of them. Okay, what tools are they looking for? Somebody in math or computer science? I will walk you through the slides now, but in this domain, you'll work with mathematicians. If you're not a mathematician yourself, you'll work with math and computer science, information system analyst. They all work together because this domain is particular for that. Okay, solid knowledge of R statistical tool. So there is a language that's called R, very famous language. The beauty of R, if your company hired 5 or 6 mathematicians and you come up with Python, Python is awesome, it's an excellent language. But can you work with these mathematicians? And really the work project, if they share, that happened to me. There is this company that wants to recommend movies to people. They are releasing their application early 22, like January 22. It collects our Hulu, Netflix, and Amazon Prime videos into one application. And they need their own recommendation system to tell you what's to watch, because Netflix is going to recommend Netflix and Hulu is going to recommend Hulu shows. So they need to build their own. We took in that project. Now we are handling it. And I'm the director of that project here at ETSU. So we're really making a lot of let's say, progress out there, and people need our skills. But in short, R is a way to communicate with mathematicians. So using that language has that power. Or relevant software packages. They want SQL, Excel, and that's it. And Python. So in this course, like I said, we will talk about all of these. Just in this syllabus, you will find that these things map immediately to the industry and the jobs that are being posted out there. So let's take it from the beginning. I'm Dr. Gate Husari. This is my office. It's in Nix Hall, 460. My office hours are on Thursdays, 2 to 4. And these office hours are available to in-person or a Zoom meeting. A Zoom link of my office hours will be posted on D2L. This is my email. I forgot to add a line. I'll add it later. There's another line that goes under this that says others by appointment. So these are not the only times that I'm available. Just shoot me an email if these don't work for you, and we'll work something out. The textbooks in this class, here are 6 textbooks that I used in the creation of this. And this is very normal because the objective here is not to get to the finish line. It's to map the things we do here to the industry. So it's basically we're trying to keep a balance. So you are required to purchase these 6 textbooks. They don't cost something above 700. So I'm just kidding. No, you're not required to buy any of these. It's these are recommended, all optional. The Great Library of ETSU has purchased a fantastic book for us. It's my #1 here. Data Mining, Concepts and Techniques. And I posted a link to that book on D2L. ETSU already bought that book, so you'll be able to have access to that. And it's a huge help in this course. The grades in this course, there's going to be 11 quizzes, 11 labs, each of which is 25% of the entire course grade. There is 15% on midterm, 15% on project, and 20% on the final. If you have a certain problem that you want to do in research, and we have a lot of problems, what we don't have is people who want to solve these problems. If you have a plan to do some research, let me know, and we can change these grades based on certain things. For example, if you're an honor student and you wanna work on an honor thesis, we can remove a big part of the final exam or altogether and move it towards the project, and that way you get to work on your research problem and let's say replace some course deliverables with that work. You'll be the owner of that work. You just get to do it through the course in a step-by-step manner. All right. Let me share the slides. All right, online people, can you see this, the slides? All right, fantastic. So what is data mining? Every teaching tips book says millennials and Gen X, they don't like to know what before the why. So we start with the why. Why data analytics? Why this class? Well, data analytics is basically the new business ecosystem that wants to make decisions not based on people experience. People experience is always important, but we want those experiences to be supported by data. So, in short, we will collect a lot of data and build a system based on this data. This system will try to answer a business question. But who comes up with this question? How does this really get, well, how does this go? There are two ways to do this data thing: data science and data analytics. Very different ways of doing things. Let me explain. Data science, I'll give you the data, and I tell you, hey, can you make the world better? Can you help us achieve our objectives? So you don't really have a real, or excuse me, a specific question. You have a general question. For example, I give you all the student data, and I tell you, hey, how can we guide students to do more research? That's it. And there is data analytics. Data analytics is different. You have a business question. Somebody comes to you. It's much more specific. Somebody comes to you and tell you, how can we reduce the number of students who do not do research? Very specific question. Give me how to reduce the number. And then we need to create an approach to answer that question. Lucky for us, there is a generic approach. It's like our map, our blueprint on how to do data analytics. It always begins with the data. What kind of data you have for me? If we have the data, we need to know how does that look like in terms of what's the quality of the data? No, this is just a bug in, I solved it. Okay, so in short, once we begin here with the data, what does our data look like? Is it images? In radiology, if you work for a hospital, they're going to give you images. I worked on a project like that in 2010. Basically, the hospital had a lot of images of brains, and they just want the machine learning model to look at the image and say, this is a brain hemorrhage or a brain tumor or a normal brain. Why? It's not going to replace the doctor, but it's a support thing for the doctor. So if the doctor disagrees with the model, it just requires another layer of checking because a human makes mistakes, right? So if the machine says something is bad and the doctor says no, the doctor will just recheck. So is it images? Is it student data? Another project that we are collaborating on is a project we take all the student data 10 years to this day. Then we categorize all the courses students take. This is a very well-paid project. I'm talking not about like, I'm talking about these are major projects. You group the courses into math, science, literature, and the programming. Things like that. Like we have 6 or 7 categories. Then we give you each student a score in this category, like A, C, B, and then we see what happened with the student. Did they drop out? Did they go to another school? Did they get hired after? Did they get hired before the degree? Or are they still looking for a job? Based on these, I can ask the question, what's your name?
Drew.
Drew. We can ask the question, who does Drew looks like of my data 10 years ago? You see the personalized marketing? I take him, his progress so far, and I ask the question, who does he look like from my data? How can I predict for him? Every one of us is unique, but we need to do this. Adidas, for example, we won second place 1 year ago here in ETSU in a competition, data analytics competition by Adidas. Adidas generates new designs of shirts. These designs have never been seen before, right? It's how the business works. How can we predict something that we never saw before? It's not a logical question, right? It's something that you see for the first time. Well, in week 2, starting next week, we will show you how to measure the similarity between any 2 things. We can measure the similarity between a computer and a door. Once we measure that similarity, we will start predicting what I know to something that I've never saw before. So the type of data could be images, could be student data. It could be like audio recordings. There is a project that here we are collaborating. Why am I mentioning these projects? If you like any of them, let me know. I'll try to hook you up with the people who are doing it, and I'm collaborating with that. So we'll map some course deliverables to that. We have recordings. These are not publicly available. These recordings are for psychiatric sessions. And basically, when people talk, that's an audio. There are tools that will convert this audio into a text. And the big question becomes, what can we learn from this text to help people who are posting on blogs online? How can we see any similarities? Maybe this is a very, let's say, this research is in infancy. So we're not looking to provide an on-the-ground, like automated psychiatrist. That's crazy. But if you can extract that this post probably suffers from X or Y, then you can provide guidance and help and reach. So the type of data is very important. Okay, so once you have this data, let's assume this data comes in JSON. The company, the first thing, or in Ruby, some data comes in that. And then the company will ask you, hey, can you convert this to something else? We want it in SQL, or we want it in CSV. So we should be able to do that. And one tool that helps us is the Oracle developer. I'll show you a demo in 1 or 2 weeks on how to use that tool. Once we have the data, we can move to something called data warehousing and integration, because the data does not come from one source. One of the projects I worked on, it's an ICU data. You know, patients in the ICU. Patients in the ICU, you get the data that you get from the ICU. What's their OSAT, and other stuff, like their pulse and heart rate, and which patients expired and which patient got released. That's the data from the ICU, but that's not the only data. You go to the lab system of the hospital, they'll give you another data about what tests they did they do and what's the results of those tests. You combine these two together. How? In this process, phase 2, data integration. We need to integrate this data together, and this is not easy. If you make a mistake, it's going to be very hard to discover that mistake here when you come up with decisions. In 2019, I was called to help on a project that was stuck for months, maybe weeks, but let's go with months. So I went there, and 10 minutes in, I discovered a silly mistake the lead researcher did. Instead of providing, when they integrated the data, they provided the the row number +1. So each row from one data set was mapped to the row below it in the other data set, which confused the machine learning model, because now you're giving it like very wrong information. You're confusing the model, right? So when you build an AI model, you must give it correct data. But you cannot say, hey, Gate is a successful researcher. Gate has brought a lot of grants. Gate graduated 10 master students. Gate got fired. You're confusing the machine learning model. Like, how do you expect it to give you correct decision? Because you're feeding it false information. So data integration is a very important process. We must do it with ease and double check. Like, have we integrated this correctly? These 3 steps, we're going to do them extensively in this course. All right. Once you do that, then it comes the selection process. You have massive data. Is all this data important? Who gets to say that? Us? Of course not, right? A human does not make that decision, should not make that decision. You cannot know which column is important. You don't know. Even if somebody asks you something silly, like, for example, if you have a part-time job, is that important to which, let's say, to which year you graduate? Is your hair thickness related to your grade? Really, that's a research question. Is it? Maybe, we don't know. Maybe you have thick hair, you get distracted by other stuff, and you perform poorly in school. We don't know. We can't answer questions like that, no matter how silly the question is. We can't answer it, right? Because the data must say what's the relationship. So selecting in this process is basically 2 steps. Cleaning irrelevant data, even if the data looks important. Let's say you are doing a lung cancer research. All the data, they all have lung cancer. There is a lung cancer column that says true for everybody, because it's a data comes from lung cancer. Is that column important? Of course not. Why? Because everything is true. When everything is true, nothing distinguishes X from Y. It's all the same to that column. So you remove it. How do we do that? Cleaning process. We're going to learn how to do that in week 2. And then in week 5, we will learn how to sacrifice a little bit of accuracy, like 5% of accuracy, but get rid of 50% of the data. You sacrifice a little bit of accuracy, but 50% of the data, not important. They just contribute 5%. So you just take them out. That's called PCA, or Principal Component Analysis. That's like week 5. Then comes this process. They call this predictive analytics. So if you talk to a CEO, they might not understand or talk in a fine grain. They might say, we are looking for somebody to do descriptive analytics, or we're looking for somebody to do predictive. The descriptive analytics is before this circle. All what we talked about are descriptive analytics. Here, we talk about predictive. Predictive analytics is building a statistical model, a machine learning model that will predict the future based on the data that we have. This model mostly extracts patterns. These patterns, like the type of degree you have, the type of income you have, How much revenue did you bring to the company? How many years have you stayed with this company? With this pattern, it's going to give you a yes or no question about something. We have to come up with that question. What's our yes and no? For example, who gets promoted? We ask that question. We need to see if the machine can help us predicting that. Once we do this, then we move to the evaluation. So you come up with a decision. Yes, this person is going to get promoted or fired. What's your confidence? We must provide a confidence with everything. Even the COVID test, they do the exact same thing. When you get tested for COVID, they tell you something like, the recall is 90% and the precision is 80%. Okay, what does that mean? We're going to learn that in week 7, how to assess our models and provide numbers. When somebody says the recall is 90%, that means the test discovers 90% of all COVID patients. All patients who have COVID, this test captures 90% of them. In other words, 10% of people who have COVID will go undetected. Okay, precision is 80%. What does that mean? Precision 80% means when the test says somebody have COVID, we are only 80% sure that he or she have COVID. So in short, when you have low precision, the model is gonna say a lot of wrong things. It might capture all the people who have COVID, but it's gonna mistakenly tell a lot about healthy people having COVID. So all of this goes to pattern evaluation. There is no such thing as 100%. So we have to provide to which degree are we sure. In business, in this domain, we're gonna work a lot of with people in business. They work with this thing like this. First, they start from the data. Then you do the data pre-processing, which means cleaning the data. Have you ever collected data from people? It's gonna drive you crazy. For example, you ask something simple as gender. Some people will write male, female, M, F, man, woman, lady, boy. It's gonna be all over. You can't feed that to the machine learning. That's just rubbish. Like if you give it to the machine learning is not smart. It's not gonna know that lady means woman means female. God no. We have to clean it and tell it that. And we're gonna do that next week. So in the next week, we're gonna learn what kind of mistakes we have and how to fix them and how to write rules automatically to visualize them. Visualizing the data is very important. If I give you 1 million records, how are you going to check them manually? Good luck. We're going to learn automatically how to detect those errors and fix them. So that's data pre-processing, and that's week 2. Then we have exploration, which basically looks at the summary of things. For example, you get to ask a question, what's the average income by those employees? That's a statistical question. Why the average is important? Well, let's assume we ask the question now, how much each of us make a year? Let's assume we ask that question. I mean, we're not asking it, but let's assume we do so. Some of us, or one of us, might have an extensively higher salary than everybody else has. It's going to ruin the salary, it's going to ruin the average. So if I'm collecting the average and somebody has a much higher salary, it's going to change the entire average of us, right? Which is not fair. So to clean this data, we can say anybody who's higher than the average by this amount, by 10,000, take them out of the data. Because you're too far from everyone else's. So either you are lying or you don't belong to this group. Your number got captured by mistake. Somebody made a mistake. Like when they collected the data, they collected your data. Actually, we should not have collected your data in the first place. Does that make sense? So statistical measures are very important. Then we go to information discovery. We try to extract things that make sense from the business decision. We visualize the data, and finally, we provide a decision for the business. This decision says, okay, anybody who graduated from this school, fire them, because nobody ever made tenure using that particular background. And it's up to the business. Of course, there is confidence that goes with that. Probably the confidence is going to be something like 70%, and it's up to the business people. That's above our pay level. Like, what do we stop when we provide a decision with a confidence level? And this is another way of looking at it, but this one shows you more what we do in this course. This breaks out the process. Like, how do we do pre-processing? How do we do data mining using these things? So these will map to weeks. If you go to the syllabus, you will find that these operations, they can be mapped into weeks in our syllabus. We talked about medical. We talked about the types of data, the images. So when you go to Walmart or any store, they save the data in a certain setting, right? You go there and you go to this aisle where they put things next to each other. This is not a decision that was made by the workers there. It's not a decision that was made by the manager there. It's a decision that comes from their data analytics approach. It's the data. How do people buy things? For example, beer and diapers. This is a big question, in like not the beer and diaper itself. It's just this is what everybody uses. But what do people buy together, and how do we really extract that? It's not a frequency, let me tell you. I mean, one answer is, well, we measure how many times do people buy beer and diaper together, and that's it, right? We're done. Now, let me shed another light. If somebody collects our data here in this class, attendance data, which is me and everyone else here, the frequency is going to be very high, right? But then you look closely, ask a different question. If gate does not come, how many of you come here? So basically, if you only collect the frequency, your frequencies together will be high because you always appear together. But is it really, or is it someone else's? So basically, if gate does not come, do you all also come together? So that's how data analytics asks questions. It's not a matter of frequency. It's a matter of this is what we call association and correlation. And we're going to learn how to do these things automatically. Then we go to a little bit more advanced questions, in which I'll give you data about people who applied for loans. And then you train a machine learning model and come back and you start answering questions. The model starts answering questions. Who's going to get approved and who's going to get rejected before that person really applies? And that's called the classification, which in short, you take in the data and you make a decision, either 0 or 1, either approve or disapprove, like or dislike. Classification, sometimes it's not 0 and 1. Sometimes it's A, B, C, D. But if you look at the implementation, it's always 0, 1. Even an implementation that tells you this student is going to get an A, this student is going to get a B. The real question inside the machine learning model is this student going to get an A, 0 or 1? Answer me yes or no. That's how really it works. It's always a yes or no question, but it's sometimes multi-layered. Another big problem is clustering. Clustering is a totally different problem. And sometimes it's part of the pre-processing. Clustering is grouping things together automatically. If you work for a newspaper or an online service where they have a lot of blogs, let's assume you have 16 million user blogs, how you're going to begin to handle those? It's 16 million. How do we group them together? How can we, instead of reading the 16 million, tell me how many groups they are? The machine learning is very strong at doing this. It can group them and it can tell you something like, I think the best way is to group those people into 8. Where did 8 come from? Machine learning is very good at this. It's going to tell you 8. Once you have these 8 groups, you can just randomly select 20 from each and read them manually or analyze them and make some decisions. So clustering is a different problem where we group things together in an automated manner. Last week in this course is going to be something called outlier analysis. Outliers are extremely painful to deal with. Why? Outliers are things that make sense, but they're really either mistakes or lies. For example, what if I told you the temperature in Johnson City is 100 degrees? Does that make sense? What if I tell you the degree now outside is 90 degrees? The temperature right now is 90 degrees. Does that make sense? Great. What if it's winter? Does it still make sense? Okay, how do you discover these things? Like winter and summer, this is a human intelligence, not machine intelligence. How does the machine capture this? It's very hard. And it's not just two, it's not just summer and winter. It's inside and outside, in shade or under the sun. The questions are really not limitless, but they're really like too much. So how can we do this outlier analysis? Outlier analysis is extremely important step to clean the data, because the data sometimes is dirty. Either somebody lied or somebody made a mistake. Do you know who uses this? The IRS. That's how they discover fraud. Something that doesn't make sense. So you have a car wash that made 10 million. Yes, some businesses make 10 million. A car wash in Wyoming making 10 million. Okay, during the summer or during winter. How do they discover these things? Outlier analysis. You are telling me that you made this much in winter in Wyoming and during COVID. Outlier analysis discovers anomalies, things that don't make sense, things that need investigation. Do you know where else I use it? In my research, we use it for cybersecurity. If I listen now to you, has anybody used Wireshark before? Yes, Rachel, I saw you raising your hand. Wireshark listens to the network data. The network data is encrypted. You can't really, so the network data is like packets. So a packet looks something like this. This packet is encrypted. I cannot know what's inside. But the flow of information, the flow of packets between all of you, if you are infected by a malware, it's going to be different. And when it's different, we can really detect it as an outlier. So it needs investigation. Probably it's a cyber attack. We've been hacked. That's outlier analysis. A lot of people interested in trends. If somebody buys this, that's why we get annoyed by Facebook. Have you ever tried to shop for something and suddenly Facebook's showing you all of these ads about the same thing? It happens, right? That's how it happens. You shop for something, they have an algorithm that tells them what they should tell you now, how they should approach you about which products. You buy a camera or you're shopping for a camera. Then they show you a memory card. Why? The data says that, not a human. The human often does not make those decisions because sometimes it's forbidden by law. Let me give you a very tangible example. Walmart sometimes locks things as an anti-stealing, like they lock them in bags, right? Have you ever seen something like that? So you try to buy something, but you have to go unlock it at the cash or a registry. How do they do that? Who makes this decision? It's not a human, let me tell you. Why? Because this escalates really quickly. Because what are you locking? There has been a big problem in Walmart about locking certain types of makeup. So why are you locking makeup? Contraceptive. Are you profiling people? Somebody can ask, a lawyer can ask, and this escalates really quickly. So let me tell you, a person does not make that decision. The machine must make those decisions. And that's what Walmart answered. Their data analyst representative came up to the people and said something like, hey, we do not lock baby stuff like the milk. We do not do these things. What we do, we have an algorithm that checks what kind of products get stolen, and the algorithm tells us what we should lock. And when I tried to buy, what do you call it? A baby thing, like baby food. It was locked. I was like, why are you locking baby food? I'm just curious. Like, it's not that expensive. Like, it's 14 bucks. And he says, it's an algorithm, not us. The data says lock it, we lock it because it gets stolen. It's as simple as that. So anyway, these things get used all the time. Also in medicine, when you take certain medications or when you have a certain features like gender, age, disease, all of these together, they also combine with what kind of medications should be suggested. Another system I'm collaborating on, and this is also a potential project for you. And by the way, all of these projects can become master thesis or honor thesis. Doctors, when they write about us in the hospital, when we get sick, they write in text, right? They grab a keyboard and they start writing, oh, the patient has this or that. This information must be translated into a protocol. So basically, for example, hypertension must be mapped to something like this. ICD stands for something, disease category, 190. ICD 190 is basically the code for that disease. The doctors, why must they write it? Because the entire world is not English. You could fly somewhere else where they don't know what that doctor has written. That's why the code is there. So your medical profile will be internationally agreed on. That's why it's so famous, the ICD protocol. You just type a piece of code and the entire world understand what that means. Does that make sense? Now doctors make mistakes. They write something like, oh, this patient has hypertension. But they, instead of ICD 90 or 190, they type 91. Human make mistakes. How can that be detected? Who's going to really detect that? Do you think we can hire doctors like with their insane salaries to sit there and read and check your data and say, yeah, that looks okay, let's go to next patient? Who's going to pay for that? Instead, they pay us. They create a project to handle multiple universities and schools, and hospitals. Then you do text analysis. How do you do it? You see what doctors write about ICD, because you cannot write something and says, this is what ICD. Somebody might write hypertension, somebody else might write high blood pressure, something like that. So you teach the machine, this ICD means this. Now give me all the anomalies, give me all the things that don't match, and try to correct the doctor, like an anti-misspelling. When you misspell something, it gets corrected, right? Same concept. When you write about a disease, but you write a different code, the system is going to tell you, did you mean this or that? This is one of the projects. It's still under development. Now is the time to jump on board in the data analytics field, because everything is new. Everybody's learning. So no matter what you do, it's going to be probably a new area. So if any of these projects intrigues you, please, you can do it as a course project. You can replace the final with it, final test, add it to the course project, and dip your toe, see if this is your thing. If it is, you go on with it. One of my students, he wants to predict real estate here in Tri-City area. Can you imagine an app that tells you how much your real estate is going to be worth in 5 years? Looks important, right? I'd use it, personally, I'd use it, not like for fun, not because I'm a great businessman, but for fun. Like you want to buy a piece of apartment or a condo or not a piece, a condo or apartment. Or it's nice to know what's it's going to be worth in 3 or 4 years. So that's another like market that you can, but it's not easy. Like, how do you do that? Because it's connected to the school. How many students do we have in our schools? How many students do we have at ETSU? Because ETSU is a college city, right? So you must take data from those sources as well, compile it all together to make those decisions. What kind of science we have here? A lot of science. We will be doing like over 12 forms of visualizations and knowing what they mean and how we make decisions based on those visualizations. Visualizations, making data as figures, serves 2 purposes. One, for us, there are certain visualizations that we make for us to make a decision. Should we go forward or go back? Sometimes in the data analytics process, you don't know, should I march forward or do I need more data? Sometimes your data sucks, like that's the way it is. You have a data that's just not descriptive. It's not gonna get you there. So when do we know? We know by those visualizations. You take a look at the data and you simply say, this is gonna be a hard project. Let me give you an example. Variance represents how much the data differs from each other. If somebody gives you a project that looks like this, the data is very well condensed together, it's going to be a tough project for sure, because it's not going to be easy differentiating those points from each other. They are very similar. If your machine learning model slips a tiny bit, it's going to make the bad decision. That's basically. So visualizations help a lot. When you visualize the data, you can make decisions about it. Statistics, we're going to be also learning some statistics. We're going to have examples and we will see. We are not extremely interested in calculating things with hand or by hand. We will be using automated tools, Python and R, to do that. But it's extremely important to know what it means. If we don't know what something means, there is no point of calculating it. So yes, we'll see how we can calculate the standard deviation, the chi-square, and other measures. But without knowing what each of these mean and what decisions we should make based on it, we are not progressing in this course. So knowing the meaning and the indication of each of these is basically our main mission. We're going to talk about pattern recognition. This question, a student of mine is responsible for a data about a prison. So some questions that get asked: what are our future needs? Because that's let's talk about hotels. It's a very similar problem, but let's talk about hotels. A hotel has many residents. When a new residents arrive, the hotel must make a decision. Am I going to be able to handle those? If not, we need to make a deal with another hotel and start directing our guests to another hotel. That's how people make money. So pattern recognition will tell you the date, the day of the year, which month of the year this is, which time, where is your location. It's going to predict whether or not you'll be able to handle the incoming guests or not. Machine learning applications, algorithms, we will discuss these at length. However, our focus is basically here. We're going to learn a lot of visualization, statistics, how to recognize patterns, and how to apply machine learning. These are important, but for example, the algorithms, the algorithm that learns, we will discuss it, but learning how the algorithms make the decision, while we will describe it, it's not our main objective here. Why? The algorithm, here is how it goes. You give it the data, the algorithm learns and start coming back to you with decisions. You measure the ability of the algorithm to make the decisions. Learning how the algorithm exactly works, sometimes it's not possible, like in neural network. In deep network, nobody knows how the algorithm works, really. We know it works very well, but nobody knows how it works. When the time comes, I'll explain to you. Some people try to build another machine learning to tell us what it means. Like a machine learning from a machine to tell us, to translate to us what it means. It's like a human brain. The neural network was built based on the human brain because we have neurons also working together. But to this day, nobody can tell you what's going on with the algorithm. We only can tell you it works. And it's really achieves very high accuracy, but we don't know how it makes those decisions. If this is the field that you're interested in, to come up with your own new algorithm, for example, there's something called neural network. If you want to come up with your own algorithm, there is another class called machine learning that focuses on the theory and how these algorithms make these mathematical decisions to get to that. So the main problems here we have is complex types of data. Sometimes the data is just complex. We have to work with it. Let me give you an example. Sometimes I ask you, which year are you? Like in what year this is, which studying year this is for you? You will answer 1, 2, 3, 4. The machine sometimes does not understand that 3 is higher than 1. So we need to find a way to tell it that. It's not, sometimes we need to jump through these hoops, the complexity. Because if the machine thinks that 1, 2, 3, 4 are categories, like blonde, brunette, and redhead, so redhead is not higher than blonde, right? If the machine does not understand 1, 2, 3, 4 are numerical, and we'll talk about next week, it's going to make bad decisions because it doesn't understand that a fifth-year student is more advanced than a first-year student. If we don't make that that knowledge, the accuracy is not going to be good, and the machine will not learn very well.